Hi, everybody. I'm Seth, and I'm going to talk about the IPv4 Unicast Extensions Project. So thanks to Nanog for having me, and thank you all for joining in, and looking forward to it, and sorry not to be there in person. So we have a small project that's been going for a couple of years that has attracted a fair amount of attention and controversy. And our project aims to reduce the degree to which IPv4 addresses are going to waste. This project is led by John Gilmore, and we've had a couple of collaborators and a couple of co-authors. And a number of people have helped us out by discussing the early history of IPv4. So we've been able to learn more about how all of these things came to be. We have 4 internet drafts that are proposing to unreserve 4 kinds of IPv4 addresses. And we're asking software implementers to treat these as ordinary unicast addresses. The 4 kinds of addresses, which I'll go through one by one, are each reserved for a historical reason and are not really helping people today. In many cases, those purposes for which they were reserved didn't really come to fruition or didn't become significant in the way that the internet standards community thought in the 80s. So by making these changes, we have the potential to free up a lot of IPv4 address space. Now, of course, not all of these addresses would be usable right away. They all have compatibility challenges and routability challenges. But we'd like to test how well they would work together with the measurement community and have the intention that someday the internet community will have the option of allocating these addresses for unicast use to number ordinary internet hosts. So in the 80s, it was less clear whether the internet would be an experiment or a global infrastructure. Scarcity began to loom on the horizon, but it was certainly much less of a concrete experience and a practical concern than it is now. And there were various decisions that were taken for various reasons to treat certain addresses specially, so that instead of being available to number hosts like other addresses, they were often required by standards not to be used, saying implementations must not generate packets to these addresses or must not accept them or must interpret them in a particular way other than numbering a host. In retrospect, we can now see that a lot of those decisions have not proven to be helpful, but they're continuing to prevent large amounts of address space from being used for unicast. So these are our 4 drafts for 4 kinds of addresses. We presented the first 2 at IETF 112, and a lot of you may have heard especially about our 127 draft, which is probably the most controversial and the one that has been most discussed. And I'm going to go through and talk about the specific kinds of addresses. We're talking about the software work we've been doing, what the picture looks like for each of these. And this is a recording, but I will be available on the day of the presentation for live questions at the end. Okay, so the first category of addresses that I'm going to talk about is the lowest address in every subnet. So if we have an address like this, /24, there are 2 versions of the broadcast address, the lowest address on the subnet and the highest address on the subnet. It turns out that TCP/IP implementers in the 80s made 2 different choices about which address would be used for broadcast. The highest address, in this case 255 in a /24, won out in terms of where the standards ended up and where the recommendations and documentation ended up. But documentation continued to note that for backwards compatibility with BSD systems from 1983, you should continue to reserve the lowest address as well, even though there was no specific reason for anyone to be using it and documentation advised against it. So this continues to waste 1 address for every subnet. If you had a /28, for example, the fact that you have 2 broadcast addresses instead of just 1 would be fully a 16th of the addresses on that network. And as you subnet smaller and smaller, the addresses that you lose to duplicative broadcast add up. One interesting thing about this, which is different from the other kinds of addresses that we're talking about unreserving, is that you can actually, under existing standards, unilaterally fix this on your own network and interoperate under existing standards with the rest of the internet. So this is to say that hosts that are not on your subnet are already forbidden from assuming what netmask you're using because they don't know where your subnet boundaries inside your network are. So if your router and your host interpret the lowest address as a non-broadcast address, the rest of the internet should already interoperate with it. And you can find some sort of practical examples of this on the AWS EC2 reachability page. They have quite a few hosts that you can ping to see about your ability to reach EC2, to reach various data centers. And a lot of them actually end in .0. And of course, we don't know what their subnets are. We don't know what their netmasks are, which is kind of the point. But if we think of some of them as being potentially the equivalent of a /24, you can see that typically operating systems and typically routers are able to reach these. And so essentially the standards changes and software changes that we're proposing in this regard would let everyone do the same thing that perhaps AWS is doing here and get one extra address per subnet without requiring any changes on anyone else's part. Now, that's not the case for other kinds of addresses, which I'll go through. The largest block, and this is a much discussed topic, is the experimental, the former Class E range. That's everything from 240 on up to the end of the IPv4 space. And this was a decision from 1983 to reserve these for future use. There was a lot of reason at the time why people might have wanted to do that, because they didn't know whether there would be new kinds of addressing and new kinds of modes with different semantics. For example, if you look at the RFC that first introduced the Anycast concept, it originally proposed that Anycast services ought to have their own dedicated address range. That turns out not to be the way that we do Anycast nowadays, but that was a proposal at the time, and there were a number of proposals in the early days about different kinds of addressing with different meanings. Multicast was another one that was actually carved out of the original Class D block, which was split into Class D and Class E. And there are other ideas for new addressing modes, but none of them have been brought into use except for the multicast in 224/4. And today, it's extremely unlikely that new IPv4 addressing modes will be invented and actually deployed. And so these addresses that continue to be reserved for future use are going to waste. A smaller network that's also reserved due to a very early decision in 1981, before we had DHCP and more modern auto-configuration mechanisms, there was a proposal for an ICMP-based auto-configuration mechanism that would perform some of the tasks that we now accomplish with DHCP. The entire 0 network, 0/8, was reserved essentially so that this ICMP auto-configuration mechanism could use it. In my understanding, when you connected your computer to a network, it would use a 0 net address and then send ICMP messages and get ICMP replies. That mechanism was deprecated in 1989. I'm not even sure if it's ever been implemented. And of course, now we use BootP and later DHCP and auto-configuration mechanisms that only use a single address, the all zeros address, rather than first octet 0. So these addresses are still reserved for this thing that was deprecated in 1989. Okay, loopback. Now, this has raised a lot of controversy and a lot of discussion. But IPv6 has only a single loopback address, the :1, where, due to a decision back in 1986, IPv4 has 2^24 loopback addresses, all of which are defined to mean this system. Now, it is possible to find implementations and software that use more than one IPv4 loopback address, but it's relatively uncommon to see something outside of the 127.0 being used to mean loopback. And so our draft proposes to unreserve them. We've been looking for other examples of things that may use these. We were contacted by someone who apparently has a VPN product in Japan that's using these. There was a discussion about whether the NTP server from the NTP reference implementation uses them. It turns out that it actually doesn't. It uses them in a configuration file, but doesn't actually address them. It doesn't actually number a service that's connected by a socket. So we're still interested in hearing about more things that might be using these addresses, but the overall point is that we don't actually need 2 to the 24 loopback addresses on each host. We also would like to have a discussion about multicast, because multicast is relatively little used compared to unicast, and the significant majority of the multicast range in 224/4 has not been allocated to multicast at all. So in principle, the majority of those addresses could be reclaimed. I find this to be a more complicated and more challenging matter than some of the others, partly because the allocations that were made are non-contiguous. They're more interleaved. So you have an allocated multicast address followed by a multicast block, followed by unallocated multicast blocks, and they're mixed together. So we don't actually have an internet draft about this address space, about reclaiming multicast, but it is a portion of the IPv4 space that also is significantly underused. So there's a question about how to measure how many addresses we might be able to get back by making software changes and standards changes that reinterpret these addresses. The unicast lowest address, removing the semantics of the duplicative broadcast address, is especially hard to measure because we would need to know how many subnets there are. And as I mentioned, we don't know how many subnets there are because they're not necessarily visible outside of their own networks. But we would get 1 per subnet. From 240, we'd get more than 6% of all of IPv4. And for each of the others, we would get about 0.3% of all of IPv4. And if we could reclaim portions of multicast, we would also get hundreds of millions of addresses there. So we've been working on attempting to get some of these changes into implementations. We have not attempted to get the 127 change into implementations, although we have tested it. And it worked properly on a local network. But we and other people have proposed some of the other changes that I've talked about for deployment and implementations. And a somewhat little known fact that we find very significant in terms of the feasibility and consequences of making some of these changes is that the last time that there was a major effort to unreserve 240/4 at IETF, which was in 2008, a large number of implementers, even though that draft was not adopted as an RFC, actually implemented it and made the software changes in 2008. So most operating systems now support 240/4 as unicast already, even though RFCs suggest that they should not. We've also got our patches to change the broadcast semantics in the Linux and FreeBSD mainline. And we got patches into Linux as well for 0/8 to treat it as ordinary unicast, of course, with the exception of 0.0.0.0, which is used for auto configuration. As I mentioned, we've tested changes for 127, but due to various concerns, we have not proposed that those become default behavior in operating systems to date. These changes generally are quite small, as you can imagine, and they generally consist of removing special cases in the IP implementation and then testing interoperability to make sure that configuration tools can assign the addresses and that other software will use it and all of that. But often it involves basically removing a single condition in the IP implementation, which is the condition that would have treated an address range specially, so that it returns to the default of treating it as an ordinary address. Another fairly significant thing is that typically when these changes have been made, no one has noticed. So in terms of anyone's potential concern about disruption or problems that might arise or compatibility, a lot of you already have some of these behaviors in your operating systems and probably didn't know it. Now, of course, attempting to announce these ranges in BGP and everything is much more complicated and poses a whole other set of issues. But in terms of the software changes, which are the main thing that we're proposing right now, a lot of them can actually be done and just no one notices because addresses that they don't use are no longer rejected and that doesn't specifically cause them any harm or any damage in anything. Right. We have yet to find anyone actually complaining about any of these changes breaking anything, especially the huge change to 40/4 back around 2008 and subsequently. So you might be watching this very presentation right now on a device that actually accepts 240/4 addresses as unicast. We've tried setting up Wi-Fi networks that assign those addresses internally and do NAT to the public internet. And typically clients other than Windows, Windows not having made this change, worked fine out of the box without any special configuration. They got 240/4 addresses via DHCP, they assigned them, they used them, and they could get online and use ordinary services. So Microsoft is kind of the outlier here in terms of continuing to actively forbid interoperability with these addresses. You might also find that certain CPE routers are not happy to, for example, give these addresses out via DHCP. We're interested in hearing about people's experiences with that, because that may be an interesting category of devices that's a bit more difficult in comparison to laptops and phones and so on. But I would encourage people to try this for yourself if you're curious. We were kind of pleasantly surprised. I took one of these to a conference and told people, hey, do you want a Martian address on your very own computer? And people were able to get online just fine, as long as they were not running Windows laptops. So a lot of the controversy that some of these ideas stir up is about the fact that we've had a lot of these standards since the 80s. Now they may have been established for reasons that are no longer applicable or no longer useful, but they've been in place and they've influenced implementers and influenced the behavior of implementations. And so that, of course, means that if we change that now, we have a very large installed base of systems that will potentially not recognize the changes and not interoperate. And that can be a very concrete interoperability problem, right? If you have machines A and B, and A says, cool, these addresses are valid, I can use them, and machine B says, these are Martian addresses, I can't use them, then they won't interoperate with each other. And of course, it takes time to update software, and it will take some time, and people have started the discussion to some extent of how much time it will take to get significant software updates rolled out to define the addresses that we're talking about as valid and usable. So this is a good reason that we should have made these changes back in 2008, because we would have all of this time elapsed since then. It's a good reason that we should have made these changes back in 1999. And it's a good reason that we should start making these changes now in order to keep our options open for the future. So there's the famous saying, the best time to plant a tree was 30 years ago, and the second best time is now. And I keep coming back to that in terms of talking about this, because I fully understand that we are not going to have universal compatibility. If the IETF were to publish all of these as an RFC tomorrow, we would not have universal compatibility or extremely widespread compatibility for some years, although we want to do empirical measurements and find out, concretely what that looks like. But we fully understand that it would be years before software support was in place to make some of these addresses usable for certain purposes. Our view is that this is something that we regret and can regret not having started earlier, and that if we don't start it now, we may have cause to regret in the future that we didn't start it now. We would really like to work with the measurement community and try to get some empirical tests about what happens if we attempt to use reserved addresses. We don't want to do this, by surprise. We want to tell people on NOG lists. We want to discuss with the community. We want to get permission. We want to work with mainstream measurement entities. And we want to see what would happen and what can we learn about how widely reserved addresses are treated specially or are not treated specially. And we think that gathering empirical data and having recurring measurements can also inform a decision some years from now to potentially allocate historically reserved address space. Now, I like to make an analogy, and people may have questions about exactly how exact this analogy is, but I like to make an analogy to the extremely popular service at 1.1.1.1 from Cloudflare, their public recursive DNS resolver, which they launched in 2018. And they found that quite a lot of people had actually hard-coded blocking that. And on day one, when they launched it, quite a lot of people could not reach it. Now, there was not an internet standard that clearly indicated that you ought to block that, but many networks did anyway. And Cloudflare worked really hard with the community, looking into specific reports of people who couldn't reach it, doing measurements, doing tests, and working with ISPs to isolate where the routability problems were for 1.1.1.1. And they debogonized it, and they're still debogonizing it, but they've gotten to a very high reachability. So we believe that we could follow a similar process with formerly reserved addresses. Now, I imagine, but I don't know because we haven't done the measurements, that the reachability would start off considerably lower, but Cloudflare enjoyed wide public support because people understood that it was doing something useful in debogonizing addresses, in providing services with those addresses. And it got a lot of cooperation from the user and operator communities in going ahead with that debogonization process, network by network by network. So there are a lot of concerns that people have about these proposals, and a lot of reasons that they think that this may not be a useful thing to do. And we've heard quite a few of those. We've heard them at IETF when we presented. We've also heard them on lists like the NANOG list and other network operators lists. Now, most of those were focused on our draft about 127, which got really spread around quite widely and quite actively. Some of them were broader, and some of them did address the other drafts. And I'd just like to point out that the concerns about particular drafts may be different from one draft to another. And the simplest example of that is, again, with existing standards, you can already unilaterally use the lowest address if you patch your own systems. You can do that unilaterally by yourself. You don't need a new RFC. You need a new RFC in order to say that your LAN router and your host are allowed to use it, but you can also just patch them, and then you can just use it. Whereas, for the other address ranges, things can get more complicated. And they can get more complicated in different ways. So I want to just talk about a few of the most common objections and concerns that people have. And I imagine that later on in the questions, people may have others or may have elaborations on these, but I'll just mention a few of them that we've been hearing. So the most common one is presumably about IPv6 and various versions of why not just use IPv6. Do IPv6 instead. People should learn IPv6 instead. This is delaying the IPv6 rollout, various concerns like that. So I would emphasize that we favor adoption of IPv6, and we still want to mitigate the scarcity of IPv4 addresses, which continues to cause really significant pain and difficulty for lots of people. We also think that while trends that show increased use of IPv6 are a great thing, and they're definitely continuing, projections for when IPv6 would hypothetically completely replace v4, and v4 would hypothetically no longer be used or no longer be desired to be used or no longer be useful, expert projections on this seem to place it still decades away, and in some cases suggest that it will never occur. But IPv4 address scarcity pain is something that people really contend with every day. Some people have also suggested that the resources that would go into changing this, and this specifically applies most to software, would be better spent on implementing IPv6 or making things compatible with v6. And I think that in most cases, this is a false dilemma in the sense that most operating systems already have great v6 support. And it's more of an operational matter whether people can actually make use of the v6 support that they already have in software. So I don't think, at least on the software side, which is where the most changes have to happen earliest, that there are people saying, oh, I wonder if I should have my operating system capable of supporting v6. Well, maybe I'll put that off because I want to do this unicast extensions thing. We just don't think that that's actually the dilemma facing implementers. We think that the v6 software support is already there. And I would certainly agree that if there are particular devices, if there are embedded systems, if there are Wi-Fi routers that don't have good v6 support, then clearly to me, v6 support is a higher priority than making these changes. I just don't think that that's a common situation facing device makers and facing OS vendors. Now, there's also a view that nobody should work on v4 anymore, based on the idea that we want to show a unified front in our commitment to v6 and make everyone take v6 seriously. There was a long discussion. There was a IETF working group called Sunset 4, which ran from 2012 to 2018. And it specifically proposed that we should formally deprecate v4 or formally forbid IETF from continuing to maintain it. There were a lot of participants in that working group who were enthusiastic about these proposals, but these proposals did not gain an IETF-wide consensus. So current IETF policy requires in various ways that new protocols and new deployments should be compatible with v6, that you shouldn't go and invent a new protocol and make it be v4 only or something. And that seems like an extremely sensible policy, but the policy is pro v6 compatibility. There has never been an IETF-wide consensus that we should start to neglect or abandon v4, and not for lack of interest. IPv4, as I'm sure everyone here knows, is the most used network layer protocol in the world. And it's an extremely important technology that a lot of people are extraordinarily reliant on. And we don't think that neglecting it or abandoning it or deprecating it constitutes an IPv6 transition strategy. And again, I celebrate people's efforts to encourage adoption of v6 and v6 compatibility. And I think that's very important work and very good work that clearly should continue and clearly will continue. Now, another thing that we've heard is that since the demand is so high, we can really blow through IPv4 blocks very, very quickly. And the last blocks that were allocated by the RIRs went very, very quickly because there were tons of people in line and they got them. So we think that this experience is unlikely to be repeated if the allocations are willing to make use of market mechanisms and market pricing, because the market pricing for IPv4 address space has gone up quite a bit, which is something that's really incentivized more efficient uses of address space that becomes available, whether that becomes available because of legacy allocations getting sold, whether that becomes available for whatever reason. The market prices are really, really encouraging people to look closely at how they use that space. And so the demand certainly is enormous, but we think that the quantity that's demanded if the addresses are given out for free or just for administrative fees will be quite different from if they're given out at market prices. Now, in 2008, Fuller, Lear, and Meyer proposed that 240/4 should be made available for Unicast, and they proposed that at IETF, and it didn't get adopted as an RFC, though, as I mentioned, it did get adopted by a lot of software implementations. And one major concern that was raised at the time is that it's really hard today, with so many implementations out there and such a large installed base of systems on the internet, to change the semantics of address space, because then there will be systems that will disagree about what an address means. And in fact, there have been some security problems about other changes to the semantics of 127. I can get into that if people are interested, but our changes actually are better, but that's a long story about the 127 semantics. But the broader concern that people raise, understandably, is it's concerning if there are systems on the internet that interpret an address differently and the most common way that they would interpret it as legal or illegal, right? Whether you're allowed to use this address or not allowed to use this address. So people were concerned about that in 2008. They were concerned about that at IETF when we talked about our current proposals. But I would just note that implementations already disagree about whether these addresses are valid or not. And in fact, since so many implementations changed in 2008, the status quo is that there's a very widespread disagreement about whether 240/4 in particular, and to a lesser extent, other addresses that we're talking about, are valid or not. So if we want hosts to interpret all addresses in the same way, standardizing 240/4 as valid in particular is actually the most efficient way to get back to stronger consensus among implementations. So we have been doing some of our own testing. We have been numbering LANs with some of these reserved addresses, making sure that things work. We would like to scale that up. We would like to do more of that. We'd like to work with the measurement community. And just to repeat, we think it will be quite a while before it would be straightforward to allocate these addresses in the way that other unicast addresses are used. But we think that it's quite likely, just as people in 2008 may have doubted whether IPv4 would still be important in 2022, we think IPv4 will probably still be important, probably be widely used, probably numbering resources will still be desired some years from now. And of course, there's enormous economic value and hundreds of millions of dollars have been paid for large blocks. There is a opinion that we've heard a number of times, I think a minority opinion, but definitely an opinion that's represented, that IPv4 being expensive is actually good because it will encourage IPv6 adoption. And in this view, anything that makes IPv4 resources more available is actually counterproductive. So I think this could be an entire panel debate in itself about the different incentives, but we actually are not especially persuaded by this in terms of our own view of people's incentives. And, you know, the simplest way to think about this is if you are putting up a public web service that's intended to be used by the general public around the world, it's very likely that you want IPv4 numbering to be available for that service. It's very likely that you want it to be dual stack, not because of any ideological opposition to v6, just because you know that you have potential users who, in fact, only have v4 connectivity, and you want those users to be able to access that service. And that creates economic demand, which would create value for you as the operator of that site or service if it could be satisfied. So my projection is that if there comes a time when these addresses can be allocated, the most predominant use that they would see is in supporting dual stack public services in cloud hosting. Of course, it's impossible to prove that that would be the only use, but I think that that's the predominant use that we would expect to see. And we think that increases in the price of v4 resources, increases in the difficulty of getting v4 resources, again, are not themselves a v6 transition or adoption strategy. So that's all I have here, at least for the recorded presentation. And I really appreciate the opportunity to be here. I know that we're presenting something that is quite controversial and quite discussed, and I hope that I've helped you understand a little bit more of our thinking. And I'm very happy and looking forward to talking more about this. And we'll be switching over to a live question and answer session. Thanks a lot.
Thank you, Seth. Where do we have questions? Let's start with Mike first, and we'll alternate, please.
Hi, my name is Lee Howard. I'm with IPv4.global by Hilco Streambank. Also the author of Draft Howard Sunset 4 v4 Historic. So I feel like my name came up a couple times. This is a really good presentation. This was, I appreciate it. I think that of the drafts that you have, and I feel like an IETF meeting. I'm sorry, I haven't read your draft, but it seems to me that the only one that is really, so the market, excluding M&A, is transferring about 3 million addresses a month, right? So, okay, take that as an average, and you probably get, so the 127 to /8, that gets us, that feeds the demand for a little while. The only one that's really material, though, I think, is 240/4. What you didn't mention, I think, is you mentioned that all the various operating systems that can support or do support. You didn't mention routers or firewalls or things that might have logic in not hard coded but etched in silicon. What does that look like?
Thanks. Can you hear me all right?
Mm-hmm.
Yeah, thanks, and thanks for the comments and everything. And I have definitely encountered you and your name quite a number of times in this area. So it's great to see you and talk to you and hear from you. Yeah, so one thing that I did hear is some people saying that there were certain firewalls, for example, that had ASIC-based Bogon or Martian tables, not just having that as a feature in the routing table, but actually having an ASIC logic do a comparison and say, oh, that's 127, drop. And we haven't actually had that many people contact us with those details. So I feel like this is one of these unfortunate things about some of the controversy that came up, in the sense that when we make internet drafts, one of the purposes of that is to hear from people who have information that would bear on whether our drafts are good and whether they would work. And there were a lot of people who said, in terms of their enthusiasm for v6 adoption, that they were kind of mad that we were proposing these things. But there were fewer people who said, hey, I have this Juniper device. I think Juniper was one of the ones that people suggested may have ASIC-based restrictions. I have this Juniper device, and I know for a fact that it can't route some of the address ranges that you're talking about. Things like that. So I would still love to hear from people about that, because I agree that that's a gap in our knowledge. We've tried some of these to some extent, but it's a lot easier for us to get operating systems and try them out rather than backbone routers and fancy firewalls and so on. And so, yeah, if people have information about that, I agree that there's a set of concerns there about things that are in hardware. That would literally be the forklift upgrade. And we just have not had a lot of information on that, and we'd love more.
Got it. I just want to be clear that as an ardent IPv6 advocate and as an IPv4 address broker, my goal is the stability of the internet. Like, I'm not saying we should halt this work. I think this is probably really good and useful work in many ways. And so I actually support making progress with this and gathering more information on what the limitations might be, if there are some. Thank you.
Yeah, thank you very much.
We'll take our next question from the online Q&A coming to us from James Har. What is your response to concerns about putting effort into prolonging IPv4 versus investing in IPv6?
Yeah, well, I talked a little bit about that in the recorded presentation. I think that many of the contrasts that people see in terms of when people talk about software changes or standards changes, I think are often false dilemmas, that these things don't actually directly compete with each other. I think, and Lee will certainly remember this from the Sunset 4 archives, which I didn't participate in, but I have read all of as part of this project, that there is this issue about, one might say, perception management, where a number of people in Sunset 4 said, it will help v6 adoption if people feel that v4 is doomed, or maybe more positively, it will help v6 adoption if people feel that there's a really strong, broad consensus from all parts of the entire internet community around backing it. And so I feel like those things are tricky, because I understand, I also really support v6 adoption. I gave a talk many years ago to introduce v6 to some audiences, and I was very excited, and I still think it's a great thing that definitely should continue to happen and will continue to happen. But yeah, there's this issue that was discussed quite a bit in Sunset 4 about sort of, are people taking this seriously? Are they viewing it as urgent? And if we do certain kinds of maintenance work on v4, are they going to view it as less urgent? And I guess I would also be happy to continue talking about that with people, because I think that's interesting, because I would love to find ways to make v4 maintenance not be viewed as a substitute for v6, in terms of not having people say, oh, I guess because maybe 240 is going to be unreserved, I don't have to think about v6 at all. I would not want to encourage people to think in that way. I would want them to think, yeah, I need to have v6 support on my services. That if I want to maximize compatibility, I need to be dual stack. And so I'd be happy to talk to people more about that, about how to avoid that perception. I feel like from the cases we've seen and the scenarios we've seen, it mostly does feel like it's not really one or the other. That a lot of the demand, and maybe people who are involved in the broker space like Lee can speak to how true this is or how widespread this is, but a lot of the demand, I believe, comes from people who are dual stack or who are attempting to be dual stack, who understand very well that v6 is important for them. And they still know that there are a lot of networks that they want to interoperate with that are v4 only. But yeah, I'd love to talk more to people about all of those issues.
Thanks. Question from the mic.
Hi, Chris Woodfield with Twitter. I would have a lot to say about this, but that would put me at the mic for probably longer than I should be. So I'll limit to a pair of observations and a question. I've been researching this on my own recently, and one little point of fact to the what you mentioned, the false dichotomy of the effort to support this, is that I'll point out that the kernel patch to enable routing 240/4 in the Linux kernel, I think that patch got merged in 2009, was 17 lines of code excluding comments. And it's exactly what you said. It's removing the places that through errors if someone tried to configure 240/4 or if a packet came 240/4. Just in the past year, one of the major network hardware vendors added a config knob to explicitly allow routing 240/4, which personally I think is good news. So to the question is, you're talking about the interop testing that's been going on. Is there any public registry or reports or anything? Is anyone maintaining a compatibility list that people can access and contribute to at this point?
I probably should start, because since we have the internet drafts out there, there's now a public thing to point people at. We have a very out-of-date list on GitHub that I have not updated since I started working on this project in late 2020. And so it was entirely maintained by Dave, co-author who was working on the project before. So basically the answer is nothing current, but I ought to. And thank you for the prod on that. Yeah, I mean, the patches are very small. Right, we got, Dave got a 0/8 patch in the Linux kernel, which was also tiny. I got a lowest address patch in the Linux kernel, which was also tiny. We worked with FreeBSD developers to get a lowest address patch in FreeBSD, also tiny. So the operating system changes can be very small. Now there are collateral things, right, like can DHCP clients and servers accept addresses that have been reserved? And so it's not like, well, we make one change one time in one place and that's completely perfect support in all respects on an operating system. But yeah, it can be small changes. In terms of what you were saying about the good news of 240 working better, there's also sort of the fallback issue that In 2008, the other draft that existed as an internet draft at the same time proposed that 240/4 should be made RFC 1918 style private address space. And I think in the recorded talk I alluded to this, but there are unofficial uses that people are making now along those lines. And they basically have to know their own software environment to know whether that will work or not.
Yes.
And in certain software environments, it works great, and in other software environments, it would not work. But we certainly would prefer to get to a place where the addresses that we're talking about could be allocated as public global scope addresses. We know that there are empirical difficulties and empirical questions about whether that could ever occur, whether that could occur on a certain timescale. I think one thing to bear in mind is that if we make the software changes widely, and then the measurements and experiments are done and the compatibility is comparatively poor, there is still value in falling back to the private use, because then we suddenly have gotten a somewhat broadly compatible, very large amount of private address space that, if it were officially allocated as private address space, we would know would not collide with other IPv4 ranges. So that's not our top scenario, but it is something that would be valuable that could potentially come out of some of the software changes if they keep being made and deployed and tested.
Thank you.
Take the next question from the online Q&A. It's coming to us from Blake Wills. How long do you think it would take the RIRs to run out of these new addresses if they started allocating them?
That's a great question. I almost want to call Lee Howard back up and say, how long do you think it would take them to run out? Because
8 years.
8 years?
My guess is 8.
Cool. Well, I'll say Lee Howard says 8 years. That's a educated, informed guess there. Yeah, I would love to see more about the economic demand and so on, but I think that if we're talking about 240, that's a pretty large block, right? If we're talking about the individual, like 0/8, obviously that's comparatively tiny. Yeah, I wish I had more information. I would also love to hear from people who either are v4 brokers or who study the economics of this.
Thanks. Question from the mic.
Hi, Alex Bortek. I'm from Ixia. I have a proposal rather than a question. The proposal is the following. Let's create a standardized test that can be used to test routers, firewalls, switches for these blocks. There is a vendor-neutral test framework, Open Traffic Generator, that can be done for that, used for that. And then from there, you can publish results as well. That would be nice to have a repository with the test results.
Thank you very much for that suggestion. I will definitely do that. I did not happen to be familiar with Open Traffic Generator, but I will look it up and submit something there.
Yeah, I have your email, so I'll send you the link, and we can take it from there.
Yeah, thank you very much. I would love to have that in there.
Thank you.
Have time for one more question, and we'll take it online. It's from Matt Pitek. Thank you for a good talk, Seth. You asked about permissions. You have my permission to begin making these changes. Who else are you needing to get permission from to begin rolling out these changes?
So I think, one complexity we do, as one of the earlier questions pointed out, the Linux kernel actually made the 240 changes in 2009 in response to the Fuller-Lear and Meyer internet draft. And it's an interesting history, right? But it wasn't adopted as an RFC, but people said, this sounds like a good idea, and they made the change. There are certainly operating system vendors we have spoken to who say, there's no way we would make this change unless it were an RFC. And I've seen the whole gamut from we already made this change because it sounded cool to you've got to have an RFC, it's got to be official, it's got to be published by IETF before we touch this code. So I think if we really wanted to have every actively maintained operating system supporting our changes, then they would need to be RFCs from IETF. If we envision a future, which as I said is not our most preferred outcome, in which some of these address ranges become official private space, like the other draft in 2008 proposed, I really apologize for not remembering the authors' names offhand for that draft. I've read that draft like 30 times, but the names are slipping my mind. You know, that might be a lower priority if it's going to be private address space, because people could potentially say, I know that it is suitable for my application, or I know that it's not suitable for my application before deciding to use it. I think there's another interesting question about making BGP announcements without getting people too mad at us. I think that having some kind of internet body say or take note of these experiments would be helpful there. We've gotten in touch with people who make the routing reports about the bogus routes to say, if we're going to do a test, can we let you know that we may be announcing things that are officially reserved or that have been officially reserved, so that you don't complain about people who propagate those routes during our test, right? But yeah, I mean, anyone who, if it's the IETF, IRTF, maybe the RIRs, I think a fascinating thing in internet governance is always attempting to discover who apparently has the authority to officially greenlight something. I would like to see IETF or IRTF endorsing the idea of some official testing, but there could be other entities that could approve it and take note. And of course, if we're doing official testing, we will write to NOG lists and say, you know, if you see these things that you think are Martians, it may not be like something malicious, it's our test. But yeah, if there are operators who are interested in those tests or who have ideas about who should either approve them or know about them, please do get in touch with us about that, because that would also be very useful information for us.
Thank you again for your presentation and time today, Seth. Appreciate it.
Thank you very much for having me here. And sorry not to be in person. And hope you all have a great rest of the conference.